Okay, so we're looking at saturated fat content for pizzas sold by two national chains. I'll let you figure them out as we go through. We're going to check the conditions and we're going to plot the data and then we're going to look at what's what. So the first thing we're going to do is take them and put them in two different lists. Stat and edit, and take the first one and put all those numbers into L1. And I drop all those into L1. And there turns out to be 20 of them. So that tells me that here that N of brand D is 20 pizzas. And then I look over at the other one list that I've put in, and there are 15. So N of PJ, these two national brands, there's 15 pizzas. And we're going to assume that they were randomly sampled. By the way, this is 1 and a 1. Makes 11. It's supposed to be an 11, but it's just had a space there. Didn't need to. Okay, so we want to know if the two pizza chains have a statistically different.
Please excuse the following interruption. Just want to.
So are they statistically different? And our first step is going to calculate our X bars and our standard deviations for our two data sets. So stat calc 1, and we'll do L1 first. So I'll go second one and calculate X bar for Domino's. Oh, I'm sorry, for this chain is 11.25 grams with a standard deviation of 3.19 grams. And then stat calc, one of our stats, change that to a 2. So we go second 2. And we calculate. And this X bar for PJ is 6.53 grams. And standard deviation for PJ is 2.59 grams. So we're looking at our hypotheses. We've got these numbers. Statistically different means we're going to do a t-test, and we have two samples, so we're going to do a two-sample t-test. We're looking at means or averages. You got to name this somewhere, and I'll do it again on the back. So my null hypothesis is that there's no difference. So algebraically, that is this. The mu of D equals the mu of PJ. The alternative hypothesis is that the mu of D, that there is a difference. So mu of D does not equal. If there's a difference, that means they're not the same. That means not equal to PJ. Okay, so that's our first bit. We've got our numbers. So I turn the page and we look at, okay, we have a new condition that we need to look at. Instead of doing the 10% condition,
You can go ahead and release all the Junior Drive.
so we have independent group assumption. So anytime you're doing a two sample, we got to talk about the groups. Instead of doing the 10%, we can do this. We can say that the fat content for brand D, I know Brandy, is independent of the fat content for brand C. All right, there's our independent. Randomization, we're going to assume, it doesn't tell us in that opening paragraph, we're going to assume the samples are random. There's nothing wrong with being assumptions on this one. And then our nearly normal is our two graphs. So we're going to graph these. Second y equals. Turn my plot on. Go up and turn this one off. And then zoom 9. So there's my first graph, and I'm pretty happy with that. I mean, we could adjust the window. I could make this 3. I could make this 20 and graph, and that's probably even better. So I'm going to go with that one. I changed my model there. This is brand D. And so I got a box, and I got a
Please release all
box,
sophomore drivers and sophomore car
got a
riders at
box,
this time, please.
got a box, got a box. Sophomores get out of the room. Okay, so that's brand D. So now go back to second Y equals. Let's turn this one off. Press the up arrow, go over to this one, turn it on. Make sure that it says L2 because that's where my list is, and I've got that. And I'm going to press graph and see what that looks like. Oh, no, don't want that. So let's go window. It had smaller numbers, so I'm going to go 1 to 13 and then graph that. Yeah, that looks a little bit better. See them here. Okay, and this is going to be brand PJ. So I've got this box, got this box, got this box, and got that box. Okay, we're going to say that's roughly symmetric and unimodal. It's definitely unimodal, but for our content, we're good with it. So are the two graphs, what do the two graphs look like? They're both roughly symmetric. Remember, that's our whole purpose, and unimodal. So now that we have this, we're going to, conditions are met for a 2-sample t-test. T-test, because they're means. Do they need to be pooled? The answer to that is no. We never pool on a t-test.
Teachers, please
Never
go
pool
ahead
on a
and release all
t-test.
bus riders at this time, please. Release all students that
Okay,
ride a bus.
so we had this from the front side. This was 20 pizzas. This was 15 pizzas. This was 11.25 grams. This was 6, how many? 6 point what? 6.53 grams. And my standard deviations were 319 and 259. And so when we find the difference of X bar D minus X bar PJ, that excuse me, the difference between these two, this turns out to be 4.72 grams. Notice here on degrees of freedom, whoops, sorry, let me slide up. Notice here on the degrees of freedom, it says don't try it, because we're not going to do that. Let's throw another thing up here. I need to know that alpha is 0.05. Unless otherwise notified, alpha is always 0.05. So now let's do our calculations. Our standard error is found by using our formula page. And here on our formula page, we're using the standard error of sample statistics, also known as the standard deviation of variability. So we're going to find either of these two are the same thing, but I'm going to write this one. So our sample statistic is that the standard deviation of D squared over N plus the of ND, that is, plus the standard deviation of PJ squared over N PJ. And I'm not going to write those numbers because I don't want to make a mistake. We've already defined those over here. They're defined, so no reason to go anywhere else with that. Okay, so T equals X bar of D minus X bar of PJ minus 0. The 0 comes from our null hypothesis. We said they were the same, so there's no difference. That's our assumption from the get-go, and that's divided by our standard error. Now let's go to the calculator and find out what that t-value is. Stat test 2, a 2-sample t-test. It's number 4. So data L1 and L2, and we said they were not equal to. No, we don't pool, and we calculate. So there's our t-value, 4.82 and some change. So this equals 4.82. So the probability of t not equaling not equaling 4.82 is this p-value. Well, I have a lot of people that said, oh, it's 3.15. No, it can never be bigger than 1. There's a negative 5 there. Move that decimal 5 to the left, and we get 0.00003. So here's our conclusion. With a low p-value compared to alpha, here's my p-value. With a low p-value compared to alpha, we reject the null. There is very strong evidence What is there very strong evidence of? That there is a difference in the mean saturated fat contents. There's very strong evidence there is a difference running into that. There's a difference in the mean saturated fat content of brand D and brand PJ. I hope that helps. Hope that makes sense to you. And I hope you have a good rest of the day.